Hello, I'm Mark Silver. Today we're going to be processing some legacy ProMark 2 data that was collected after the week number rollover event on April 6, 2019. Now, if I use the traditional methods of just importing this data directly into GNSS Solutions or into Ashtec Solutions, it will fail. No matter what you do, I'm going to have to process the data using the latest copy of the RINEX converter. So let's do that. I've got a link down here on my taskbar. We're going to add these files, and these are the files that came from a customer. We'll change our output folder into the same folder. We'll make a RINEX folder and click on Convert. And you'll see in our RINEX folder, we now have 4 observation files. Let's check and make sure they've got a 2019 date. Okay, that's good news. So, I've got my dongle here for CGO Office. I'll stick it into the computer. That enables CGO. If you don't have a dongle, call us and we'll get you a 30-day trial serial number, and I'll make another video on how to do that. Let's start CHC Geomatics Office. We'll make a new file, confirm that. The job that we got from a customer is in East Maine, so I'm going to go to Coordinate System and default America, United States, NAD 8386, Maine East. We'll select that. And now let's go to the GNSS tab and we'll import those RINEX files. I'll change the type. Okay. The antenna manufacturer for this is Ashtec, and this is at the top. I'll show you there are other antennas listed here, but this 110454 is the correct antenna for this job. So we'll select that for each of the 6 files. And let's look. Okay. The antenna heights here. Well, first off, we need to go to the occupation names. Looks like there's 2 observations on each of 3 stations with 3 separate receivers. And I'm just going to make the station name be the serial number of the receiver. 14 6403 403 9113 113. So we've got station names that are correct based on the serial number of the device. Also, let's make a note here. The starting time looks like it's the 1st of May. The earliest time 1700. These are UTC times, and the latest time 2100. So that's about 4 hours of data. We'll need that information in a little bit. Now, our antenna height on the first occupation, 3014, I have got 1.847 meters, and that is the slant height. 1.847. That's 1.638 meters. Again, slant height. 638. And then on 913, 1.867. 867. Both of these are slants. ProMark 2. Everything looks good. Confirm that and import the data. So there are our observations. Now we need some cores data. If you right-click on the map here and choose the map type, OSM is pretty good. We'll click on confirm. And okay, so this is Lincoln, Maine. And I happen to know that there is an NGS core site in Lincoln, Maine. So let's go grab some overlapping data. So I've got the NGS website up here. We'll go to cores. Let's see, I think it is MELI. Let's see. Oh, I was right. Got it right the first time. I'm going to click on custom files. My start date is May 1st. And the start time, 1700. And UTC, the end time duration, I need 4 hours of data. Click on the M button to get down to the MEs. And we have ProMark 2s. All there is GeoSound, no need for Glass or Galileo. Another core file. Click on the core file. And NGS builds the file and pushes it out to grab that file and go over to the folder where I'm keeping everything. I'm going to make a new folder called cores. Paste this observation data and extract it. So hopefully I've got overlapping data. I'm going to need the coordinates now with WordPad so that I can see the position. There we go. We're going to need the NAD 83 position right here. Looks good. Okay, that's the numbers we're going to need. Let's go back to CGO. I want to import this cores data. There it is. Looks good. That looks good. Antenna type is correct. We'll bring it in. So I'm going to go to stations and take MELI. I'm going to right click and I'm going to convert it to a control point. So if I go to control points and click on that line, I'm going to constrain the latitude, longitude, and height. I don't actually have local coordinates for it. And I'm going to constrain them to the antenna reference point in NAD 83. So copy, longitude, and height. Confirm those changes. And I think we're ready to process those vectors. Let's go to baselines. You can see that none of them have solutions at this point. We'll click on the process button. And I'm just going to take all of the defaults, not changing anything. And I just installed CGO, so we've got a clean slate. You can see I've got a short file here, 8 minutes, 55 seconds with, looks like it didn't get a great solution. I'm just going to let that work out in the adjustment. Let's go back to stations. I click the adjust button and auto's fine. I'll click the adjust button here. And I want to look at the 3D constrained. Open the report and you'll see I get a nice report here. And the thing I'm looking at is the adjusted geodetic coordinates. Let's see, what is that? 81 microns, 50 microns. The worst latitude error is, not much. Oh, these aren't microns, these are seconds. However, if we go to grid coordinates, these are the errors in meters. So 2 millimeters, 1 millimeter, 4 millimeters, and of course we constrained to MELI. But we want feet. close that. Finish. If we go to Project, Units, main is U.S. Survey Feet, I believe. Confirm that. And go back. Rerun the adjustments. You can see we changed the feet here. That will rebuild these reports. Let's go back down. And geodetic coordinates, CCEF. Here we go. Grid coordinates. So these are feet. 100th, half a hundredth, 15 thousandths. Let's look at the elevations. This looks like a pretty good solution. I mean, the worst is a 14 thousandth of a foot on this 9113. So this is a pretty nice solution, and to be honest, I'm done with it. You can save this off if you want to store data into a usable format. If you come over here to report, there's a ground control points here that gets you a point ID, easting, northing, height. These are all meters. You can do station reports that give you the longitude, latitude, local coordinates in US feet, elevations, and we've got ellipsoid height. So you can also select all of these lines, right click and choose, say copy, Control C, and we can go to Excel, open a blank spreadsheet, paste, text import, next space, finish. There we go. Everything's in the spreadsheet format. So that's a quick tour of CGO Geomatics Office 2 from CHC. It's reasonably priced, and it appears to do a decent job with ProMark 2 and ProMark 3 data. Thanks for watching this.